Let's look at some examples. Find the equation of the line running through points A with coordinates 1, 4 and B with coordinates 3, 10. Let's start by finding the gradient between these 2 points. So we can say the gradient m of AB is equal to 10 minus 4 over 3 minus 1. 10 minus 4 is 6 over 3 minus 1, which is 2. And 6 divided by 2 gives us 3. This is our m value. So the equation for the straight line will be y is equal to 3x plus c. Now we need to substitute the coordinates of one of these points into the x and y values in the equation in order to find c. You can use either point. They will both give you the same answer. I like to use the simplest point. So I'm going to use point A with coordinates 1, 4. Now we can say y, which is our y coordinate 4, is equal to 3 multiplied by our x coordinate of 1 plus c. And we get 4 is equal to 3 multiplied by 1, which is 3, plus c. Now let's move 3 to the left-hand side, and we get 4 minus 3 is equal to c, which means that 1 is equal to c. Now we have an m value of 3 and a c value of 1. So our equation is y is equal to 3x plus 1. Let's do another example. Find the equation of the straight line passing through points C with coordinates 3, negative 1 and D with coordinates negative 4, 20. Let's start with the gradient. So we say the gradient of CD is equal to 20 minus negative 1 becomes 20 plus 1 over negative 4 minus 3. 20 plus 1 is 21 over negative 4 minus 3 is negative 7. 21 and negative 7 are both divisible by 7. We get an answer of negative 3. This is our m value. M is negative 3, so our equation becomes y is equal to negative 3x plus c. Now we need to substitute the coordinates of one point to solve for c. I'm going to use the coordinates of point C, but you can use either. Now we can say the y coordinate, negative 1, is equal to m, which we know is negative 3, multiplied by the x coordinate, which is 3, plus c. Now we can expand our brackets, and we have negative 1 is equal to negative 3 multiplied by positive 3, which gives us negative 9, plus c. Now let's move our negative 9 across, and we get negative 1 plus 9 is equal to c. Negative 1 plus 9 gives us 8, which is equal to c. Now we have an m value of negative 3 and a c value of 8. So our equation is y is equal to m negative 3x plus c, which is 8. Now we have a good idea of how to find the equation of a straight line. I'd like to look at parallel lines. From our previous video on the gradient of a straight line, we found that parallel lines have the same gradient. Let's look at how we find the equation of a line in terms of another. Find the equation of the line parallel to y is equal to 2x and passing through the point 1, 5. m gives us the gradient of the line, and m is always the coefficient of x. This line has an m value of 2, so the gradient of this line is 2. We are trying to find the equation of the line parallel to y is equal to 2x. So our line will have a gradient of 2, which means that m is equal to 2. From this, we can see that the equation of the line we are trying to find will be y is equal to 2x plus c. Now we need to find the value of c. The question tells us the line passes through the point 1, 5. So let's substitute these coordinates into x and y so we can solve for c. So we can say the y coordinate 5 is equal to m 2 multiplied by the x coordinate of 1 plus c. Now we have 5 is equal to 2 multiplied by 1, which is simply 2, plus c. Let's move 2 to the left, and we get 5 minus 2 is equal to c, which means that 3 is equal to c. Now we have an m value of 2 and a c value of 3. So the equation of our line will be y is equal to 2x plus 3. Let's do another example.